PharmOmics is a tissue and species-specific drug transcriptomics database and analytical tool. In this tutorial, I'll be running each application and providing some information about the different options and underlying methodology. The PharmOmics web server features 3 applications. The first is the drug signature overview, where you can look at a preview of differentially expressed genes, or DEGs, and pathways for each drug signature. You can also perform between species or between tissue comparisons of DEGs and pathways for each drug. To demonstrate this, I will pick dexamethasone because it has a lot of datasets across different tissues and species. Once selecting a drug, you will see its signatures, which is separated by our meta-analysis and our dose and time segregated database. Meta-signatures provide species and tissue-specific drug effects summarized across studies that may utilize different experimental parameters, whereas dose and time segregated signatures provide the drug signatures as specific dosages and treatment times in single experiments. So we're going to run a between tissue comparison with the DEGs. While this is running, I will note that you can download the gene and pathway signatures for each drug, and the full drug database is available upon reasonable request. And now we have our between tissue DEG comparison, which is visualized in this upset plot, and a table view is also available. Now I will perform a between species pathway comparison. Also, you can download the upset plot and the table results. Now you can see that I have a similar comparison results, but between species and for pathways. The second application is network-based drug repositioning and adverse drug reaction, or ADR analysis. This analysis ranks drugs based on the proximity of its transcriptomic signature to input genes as defined by a gene network model. And it also runs hepatotoxicity ADR analysis on input genes. First, select a signature type to query. You can use our meta-signatures or our dose and time segregated signatures. For dose and time segregated signatures, you can choose between using the top 500 DEGs per signature to speed up the computation without much difference in performance, or the full gene signatures. Using meta-signatures will enable a quick overview of which drugs have summary-level transcriptomic signatures closely connected to user input genes based on the gene network, whereas using dose and time segregated signatures will provide the drugs at which specific dosages and treatment times are more connected to user genes. Using dose and time segregated signatures may improve repositioning performance, since dose and exposure of the drug can differentially affect transcriptional profiles. You can then choose a network or upload a network file. Next, choose the species that matches your input gene. Since I'm going to be using the sample genes are human genes, so I will choose the human species. Repositioning using meta-signatures will take approximately 40 minutes. Top 500 genes per dose segregated signatures will take about 2 hours, and full signatures will take about 5 or 6 hours. Here I have a dose and time segregated analysis completed. The results of the analysis will show in order the most significant repositioned drugs and their tissue, species, and other context information, along with the z-score and z-score rank of the network score and p-value statistics. You can hover over the column names for more information. In addition, you can display a drug subnetwork in the browser by clicking Display Network. This subnetwork shows all input genes and their direct or one-edge connections to drug gene neighbors. Input genes are colored in red and drug genes are colored in blue. You can also move around the nodes. Adverse drug reaction information is also shown, including the hepatotoxicity network score rank of the drug signature out of other drug signatures in the database, which is based on a network proximity analysis with the Comparative Toxicogenomics Database, or CTD, liver injury signature, and there is also a link to the cite or side effect resource for the drug. At the bottom are the network scores for the input genes against the CTD full liver injury signature, as well as the 29 network submodules from the hepatotoxicity network analysis from the PharmOmics paper. The result file will have all of these results and information and will also include the genes of each drug signature and overlap with input genes. The third application is overlap or Jacquard score-based drug repositioning. This is based on the simple overlap between input genes and drug signature genes. You can input a single list of genes for unsigned Jacquard scores or up and down regulated genes to get signed Jacquard scores. For this analysis, I'm just going to use the sample genes. This analysis will take approximately 5 minutes to complete. While this is running, I'll talk about the differences between network-based and overlap-based repositioning. Overlap-based repositioning ranks drugs simply by the overlap between the drug signature and the input genes. Network-based drug repositioning considers direct and indirect functional, regulatory, or other interaction information, and the predictions may therefore have more of a mechanistic basis. Overlap-based analysis serves as a quick analysis to determine which drugs affect the expression of the input genes. Network-based analysis may be more comprehensive on which drugs will affect input genes since it also considers functional connectivity, and we predict it may have greater repositioning performance. However, this analysis takes significantly greater computation time. Another thing I can show is that you can return to any session by using your session ID. Sometimes the data can take a while to load since the result is so huge. So here we have the results for overlap-based drug repositioning. The results will show study information about the drug signature, the Jacquard score, odds ratio, p-value, and within species rank. Or this is also the percentile of the Jacquard score within the same species. At the bottom is the Jacquard score and overlap of the CTD liver injury signature and the input genes. The rank and p-value is calculated against 4,200 rat liver drug signatures as it is pointed out in the description. And you can also hover over the column headers for more information. The file output will include all this information displayed here and also the overlap between input genes and drug signature genes, as well as the drug signature genes. And you can display this in Excel as I did with the App2 results or network-based results, and this will look a lot cleaner. For more information, you can go to the tutorial for PharmOmics